Hey there, my name is Nick, and let's talk a little bit about the strategy of games with randomness. The classic example of a genre of games with randomness is gambling. So let's talk about the premise of gambling. You have to pay a certain amount of money to be able to get a chance at a reward. If I'm playing poker, I have to bet a little bit for the chance to win more. If I'm playing slot machines, I have to pay to be able to get the chance at a reward, or, even better, the jackpot. What is the strategy for gambling? I could start by giving an example in terms of game theory, but instead, let's start with an example that I can help visualize. I'll roll a pair of imaginary dice, and you call the sum of the two numbers before it hits the table. Every time you play, I'll take an imaginary Nick buck from you. Every time you guess the sum correctly, you'll get 8 Nick bucks back. If you don't, you get nothing. A serious notice first. Please gamble responsibly. Though there is no actual compensation or expense for this mental exercise, please do note that you should spend responsibly in real life, and that it is easy to get dragged into negative life experiences from gambling without restraint. How should we approach this game? First, let's talk about probability. When you take the probability that two independent things happen, that chance is the probability of one times the probability of the other. The two independent things are random results that don't rely on each other, like the result of two dice rolls. If the chance of that happening can result in multiple mutually exclusive ways, you add those probabilities together. For example, a sum of 3 can happen two ways. I first roll a 1, and then I roll a 2. Or I first roll a 2, and then I roll a 1. There is no world where I can do both in rolling a pair of dice. So, I have a table below of the probability of each happening. Do you see what's happening here? 7 is the highest likelihood of winning. All the others have a lower chance of winning. However, we're talking about spending your imaginary Nick bucks now. When I roll the dice, what are you betting on? Darn, I was betting on 7. I lost at my own imaginary game, and now I owe myself 1 imaginary Nick buck. Did you win? Do you think we should both change our strategies? How about 10 rolls of a pair of dice? I'll still bet on 7. You can bet on whatever you want. Oh no! I lost an additional 2 Nick bucks. Oh, woe is me. I won a round, gaining $8, but I spent $10 over all the rounds combined. Let's roll 100 times. A 44 Nick buck profit. How about 1,000? More than 400 profit. How about 10,000? More than 2,800 profit. Incredible. Okay. Enough betting. I was starting to get carried away there. What's the game theory strategy behind what just happened? Let me introduce the topic of expected values. An expected value is the average amount of reward you expect on getting for the chances of winning times the amount you win, minus whatever you paid, if anything. In this example, you can follow the math here. I had an expected value of 0.33 from going with 7. That more or less checks out. If I had gone with a number like 2, I would have gotten considerably less. If you look at the histograms, this checks out. As the sum of the rolls got closer and closer to their average percentage chance of happening after multiple rolls in a row, 7 was the key denominator, as we had marked in our plan. Let's see what that looks like now. So by the way, Did you change your strategy after the first roll? Clearly, 7 is the sum that we should be going for. But when an 8 showed up, how did you feel? This can gear you towards results-oriented thinking, where a random chance has a result that contradicts your strategy. It is very easy to be a victim to this pitfall, because what seems to be the evidence is staring you straight in the face. But it isn't. You just didn't see enough samples at that point to know that 7 was the clear strategy. In fact, every histogram after 100 rolls showed that 7 was the strongest strategy to follow. When it comes to randomness, expected value can help you in a pinch. Thanks for watching. I hope that you learned a little bit about randomness and expected values. In the next video, I'll be showing how to use expected values for a game that's a little bit more difficult than The Prisoner's Dilemma.